Hello YouTube. In this video I will discuss about the IoT home automation system. IoT stands for Internet of Things. The main idea behind the IoT is all the things around us, all the devices around us is connected to the internet. So from internet we can control any device, anything from anywhere in the world. So in this video I will discuss about how to control the appliances at our home using the internet. For that we need the following components. First we need the NODEMCU. The NODEMCU is a development board which has the ESP8266 microcontroller embedded into it. The ESP8266 is microcontroller with the inbuilt Wi-Fi functionality, so it will connect to the internet. 74595 serial in parallel out shift register, some LEDs for displaying the switching status, a breadboard for connecting the components, and some jumper cables for wiring. This is the circuit diagram. The 74595 shift register is a serial in parallel out shift register which has 16 pins. Pin number 16 is the VCC. Pin number 15 is connected to LED 0. Pin number 14 is the data input pin which is connected to D1 of the NODEMCU. Pin number 13 is output enable pin which is connected to ground. Pin number 12 is the latch pin connected to D2 of the NODEMCU. Pin number 11 is the clock pin which is connected to D3 of the NODEMCU. The pin number 12 and pin number 11, the clock and latch pins are connected parallel to every shift register. Pin number 10 is the master reset pin which is connected to VCC, and pin number 9 is the data output pin. The data output pin of the first shift register is connected to data input pin of the second shift register. The data output of second shift register is connected to data input pin of the third shift register, and this connection is continuing like that. This type of connection is known as daisy chaining connection. The clock and the latch pins are parallel connection, and the data pin is daisy chain connection. Pin number 8 is the ground, and from pin number 7 to pin number 1 the corresponding LEDs are connected. Pin number 1 LED 1 is connected, pin number 2 LED 2 is connected, and so on. Pin number 7 LED 7 is connected. In this circuit we can control up to 32 LEDs. For controlling more number of LEDs you have to connect an additional shift register. For controlling 33 LED you have to connect 5 shift registers. The only connection difference is the data output of the last shift register is connected to data input of the next shift register. So that's all about the hardware and circuit description. Now let's move to the software side, the programming side. In the program you have to change only 3 things. First one is the Wi-Fi username, second is the Wi-Fi password, and third is the number of shift registers used. Type the Wi-Fi user ID and Wi-Fi password within the inverted commas. In the number of shift registers you have to specify how many shift registers you are using in the circuit. If you are using only one shift register, then change the n value to 1. If you are using 10 shift registers, change the n value to 10. To upload the program to the NODEMCU board, first you have to pair the NODEMCU with Arduino IDE. For pairing that you have to do the following steps. First you have to select the file and then the preference. In the additional URL, you have to paste the URL provided in the description below. Click OK. Then select the tools, boards, and select the board manager. Scroll down to the bottom of the board manager. At the end you can see that ESP8266 by ESP8266 community. Install that board. After installing that board manager, select the tools and select the board. Scroll down to NODEMCU 1.0. Connect the NODEMCU to PC using the micro USB cable. Select the tools and select the port number, and after that click the upload button. After uploading the code, open the serial monitor and press the reset button in the NODEMCU. A website will be displayed in the serial monitor. Connect the phone to the same Wi-Fi hotspot and enter the website address. You have to connect to the same Wi-Fi network which the NODEMCU is connected. Connect the data pin of the first shift register to D1 of the NODEMCU, latch pin to D2, and clock pin to D3. Then connect the VCC and ground pins. Okay, for controlling that, you have to connect to the Wi-Fi network and click the Google Chrome and enter the website address. This is the website address, and you can see a list of numbers. This 1.1 refers to the first pin of the first IC. The 4.8 refers to the 8th pin of 4th IC. You can see turn on. It is in the off condition, so I select the 1.1 to on. Then the LED 1.1 lights up. It shows turn off. When you click the turn off button, the LED will turn off. If you want to turn on the 8th pin of the 4th IC, click here and it's turned on. For turning off, you can click again, then turn off.